Okay, part C, find the acute angle that the tangent to h at that value makes with the positive horizontal axis. So if I draw a tangent at E, this is what my tangent is going to look like. I'm looking for this angle here. Remember that the angle will equal the inverse tan of the gradient, because the gradient is equal to the tan of the angle, and that's the angle measured away from the x-axis. If this isn't in your bound book, add it to your bound book. So I'd like to find out what the gradient is there. I can do that two ways. I can take the derivative of h and make x equal E, where I could find the tangent at E and then work out what the gradient is. So this is my expression. I'd like to take the derivative with respect to x and Math 3 give x equal to E. And I need to use this E here, not the variable. And I get 2 on E. So the gradient is equal to 2 on E. Therefore, my angle will be the inverse tan of 2 on E, and I need to give my answer in degrees. So I'm going to swap my answers into degrees. I am in degrees. Degree, tangent, inverse tangent, line inverse tangent of that angle is going to be that answer, which is 36.34, which to the nearest degree is 36 degrees. I'm going to put that back into radians now. Okay, so that's part C. Part D, the tangent to the graph of h has a gradient of this. So I'd like to set the derivative of x equal to log base e of 2 and solve for x to find out where that tangent is. So the derivative of this, I'm going to get rid of that, make it equal ln of 2, that's what log base e is, solve for x, and I get two answers, 2 and 4. So if that's E and that's 2.7, do I add my tangent here at 2 or do I add my tangent here at 4? So what do I need? The tangent to the graph has a gradient, so both of these have gradients of log AC of 2, and x-intercept at the point where x-intercept at A0 where A is bigger than E. It has to have an x-intercept where A is bigger than E. If I was to attach the tangent at 2, then my x-intercept is going to be bigger than E. If I was to attach my tangent at 4, then my x-intercept is going to be less than E. So I want to choose E. So E is going to be 2 is going to be my choice. I need to put it at 2 for the x-intercept to be bigger than E. Find the y-intercept of this tangent. So what I'd like to do now is to do a tan line at x equals 2 of this expression here, h of x. So interactive calculation, tan line at x equals 2, which gives me that expression there, which is y equals, the only thing that's got an x is that, so log base e of 2x, then plus log base e of 2 squared minus 2 log base e of 2 minus 1. That's going to be my y-intercept. So the y-intercept is going to equal log base e of 2 squared minus 2 lots of log base e of 2's minus 1. Other variations will be accepted if you move this 2 up here on the logarithm. So there's the answers to that particular question.